Hi class, this is Miss Womack, and this video is just coming to go over what we've been studying with our 6 basic trig functions that will hopefully help you. And I would definitely put this in my journal as well. So we're getting much more familiar with the sine function that we see in right up here, and do take the time to and remember the technique. If we have y is equal to the sine of x, then our amplitude is going to be 1, and that is because if there's nothing listed in front of here, there's always that imaginary 1, otherwise sine wouldn't be there. And our standard, and again this one there's an imaginary 1 before the x, that's our b term, so we know that our period's 2 pi. So when we graph the general shape, again, we can just create that section like we have so many times. Make a mark out here. That mark is going to be 2 pi. And then split it in half. That's where pi would be. And this one right here would be pi halves. If you wanted to count 1 pi halves, 2 pi halves. So this little mark in between here is going to be 3 pi halves. Now, so again, you guys are doing really well. This one is not flipped. It's going to begin here at this point there. And we're looking for those significant points here, here. This one's at the bottom, and that's back up. And this is our general sine wave, right? Our parent function. Our cosine wave has a similar period. Again, you're going to do it the same way. That's going to be 2 pi. Split it in half. There's pi halves. There's 3 pi halves. And our general shape, it's going to start up here at the amplitude of 1. Passing through this point, bottoming out right here, coming back through that point, and then out this way to make this sort of kind of a B-U shape. Alright, now we then went to cosecant and secant, and the reason why is because we have to actually graph the sine wave in order to be able to see it. So for cosecant, again, just to remind you, the cups will actually be end up being on right here on our maximums and minimums off of our sine wave, which is on the paper there. So again, amplitude and period same on standard, same as sine, and also with cosine. Again, the sine wave would have kind of gone through right there like that, but we'll leave that off so you can kind of see it for the first time. Hope you're getting familiar with that. And that cup, or that vertice right there, is going to be at like pi halves, but that'll change with every one of the periods. You know, we'll label those differently just like we did the others. And this one happens to be at 3 pi halves with our asymptotes at pi and also at 2 pi. And I'll remove all of those so you can make sure you get that transferred in. And then let's look at secant really quickly down here. Very similar. This one's our inverse of cosine. So we're going to base that off the cosine wave. I'll draw that in real quick. You know, it kind of starts up here, passes through this point, goes down here, back up and back out like that. So that is why our parent function looks like it does here. And you could have completed the cup if you wanted to repeat that. I'm just choosing a section of it. Significant points that we're looking for on this one. Of course, this is going to be 2 pi, and that's going to be pi. So we have points of relativity now, and we know that our asymptotes are at pi halves and at 3 pi halves. So this is the new one that we've been studying, last but not least, the tangent and cotangent. And we've already learned that this tidbit of information, the period changed. So on our tangent line, the main thing that we want to focus on is that it will begin right here, and it goes swooping up like this and then swooping down like that. With our asymptotes, this is an entire period. So it's very interesting that this is where it's at right now. So if we wanted to identify this asymptote, if the period is pi and it's split in half by the y-axis, well, this right here is going to be pi halves, and that is negative pi halves on that side. Last one, we have cotangent, and our cotangent parent function, if we graphed it, and again, I'm just graphing, this one's similar to all of the other ones that we saw on the page except for tangent, in that it is where it begins. It begins, here's our x-axis, there's our y-axis. So this is an entire period, pi, and change of direction on that one. And this is also what ends up happening if you have a negative in front of tangent, which is kind of interesting. So there's our basic shape, our amplitude, and also our period. So that would mean that our asymptote, which is over here, since we know the period is a full pi, is actually pi. So make sure you put some good notes on there, and this should help you out with some of our basic shapes of our basic trig functions. You can also Google it. There's a lot of great videos out there. Good luck.